SV Math teacher, back one more time for our last video in transformations. And this one's all about proving similarity. A reminder that this symbol right here is the symbol for similar. And what similar means is that two objects are proportional. That means all of their angles are the same, but they've been either enlarged or shrunk. They've been dilated essentially in order to make a bigger or smaller version of the original. Think like model cars and actual cars. Those are similar objects. When you are presented with two objects that you want to try to identify as similar or not, here's the strategy that I would use. First and foremost, you want to identify corresponding sides. And I did make it kind of easy here. To me anyway, this seems kind of obvious that A to B must be correspondent to W and X. So in looking at corresponding sides, you want to look at their angle. And to measure angle on a coordinate plane, we're going to use the concept of slope. I'm going to go from A to B, and I want to make sure that that slope is the same as W to X. But I have to check each of the sides. That's what's key, right? There's four sides. I got to check it 4 times. So you'll see me do this. From A to B, I'm going to use, because I'm on a grid, if I were using ordered pairs, right, and maybe x sub 1, y sub 1 over here, I'd use the formula. But I'm not. So I'm just going to use that old standard rise over run. And if I can get my rise and run to be the same for each of my 4 corresponding sides, then I'm in business. So from A to B, I rise 1 unit, I run 1 unit. So from A to B, my slope is 1. From W to X, I rise 2 units, I run 2 units. 2 divided by 2 is 1. So the first side lines up, right? The first side, they're corresponding because they have the same slope. Let's try the second one. From B to C, it's horizontal. I remember that horizontal means my rise is 0 and my run is, in this case, 2. So I have a slope of 0. Here I have a slope of, well, 0 over 3. Now 0 over 3 is still equal to 0. All right, good. No problems there. Now I'm going to look at the bottom diagonal. I'm going to go A to D here, and I'm going to go W to Z. So I like to do my slope from the lower points to the upper points, but because I'm going to stay consistent here, I'm going to go from A to D, so down 2 and right 1. So down 2, right 1, I have a slope of negative 2. So down 1, 2, 3, 4, and 1, 2. So down 4, right 2, slope of negative 2. I'm feeling great about things right now. I got to be honest. I have zeros. My highlighting tool's a little thin here. I have zeros on the top, so those match. I have 1s on the diagonal upper left, those match. Negative 2 down here, they match. But I do have to check them all. That's kind of key. So now I'm going to go ahead and, gosh, I have a lot of clutter. Let's just change colors. Let's go from C to D and Y to Z. And because I was able to do the down and over thing, we'll do this again. So I go down 3 and I go left 2. So down 3, left 2. So I have 1.5. All right, and this one on the right, let's check it out. I'm going to go down 1, 2, 3, 4, 5, 6, and over 1, 2, 3. So down 6 and left 3, is 2. Do you see how those are different? Okay, well, we have our example then. We're trying to prove similarity. And similarity means the angles inside of two shapes are all the same. And we're finding that that is not at all the case here. While 3 of the sides, and therefore 3 of the, I guess 2 of the angles matched up, this angle right here and this angle are different because the slopes here and here are different. As soon as you identify slopes that are not matching, you know that you do not have similar figures. So we would say with confidence that the shape A, B, C, D, the shape on the left, and the shape on the right, W, X, Y, and Z, I would say not. Slashing it out because the answer is no. They are not similar because their angles are not the same, and we know that one more time because their slopes are not the same.